Hi students, good morning. Today we are teaching the first chapter, relations and functions. The first definition is a set. What is meant by a set? A set is nothing but a collection of a well-defined object. Collection of well-defined objects. Okay. Set is nothing but a collection of well-defined objects. All the sets are denoted only by the capital letters. I'll give one example. All the sets are denoted by this parenthesis 2, 4, 6, 8 and 10. So now I say A is a set because the elements 2, 4, 6, 8 and 10, you know very well, all are the even numbers. So A is a collection of all even numbers. So I say A is a set. So we collected all the even number from 2 to 10. So I say A is a set. Now we have collected the well defined, that means all are very well known 2, 4, 6, 8 and 10 all are even number. I'll give one more example. Another set B. Okay, the set B contains the element 1, 3, 5, 7 and 9. What are the relation between this number? All the numbers are odd numbers. So 1, 3, 5, 7 and 9. Now we have collected odd numbers from 1 to 9. So we say B is also a set. So that's why set is a collection of well-defined objects. The objects, it may be the numbers or the letters or the person. I'll give one more example. C. C contains the elements A, E, I, O and U. You know very well A, E, I, O, U all are vowels. So we have collected only the vowel letters. So we say C is also a set. So it is a definition of what is meant by a set. So a set is a collection of well-defined objects. I'll give one more example is not a set. Which one is give a not a set? Okay. The number of tallest person in this city is known as is not a set, because suppose I assume more than 5.5 feet is height or is the tallest person. Suppose the another person is assumed more than 5.2 feet. Okay, more than 5.2 person is said as tallest person. So the tallest is depending upon some persons are vary. Okay, so now I assume more than 5.5 feet persons are the tallest person. Or some more persons is assumed no 5.2 above 5.2 feet is the tallest person. So here we can't well define the persons. Now I say 5.5 and another one person is give 5.2. So it's an example of not a set. And I give one more example. The number of millionaire in our town. Okay, so we don't know how much money has the person. Okay, so it is also a definition of a not a set. So set is a collection of well-defined objects. Suppose we can't collect the well-defined objects, then we say he is a not a set. Now we go to some rules. The first one is ordered pair. We collect some number, pair means two values. For example, we write this now letters numbers 2, 5 or in letters A and B. So we collected the two elements within this parenthesis symbol. We say it is the ordered pair. Okay. How to connect the ordered pair? Suppose in a graph system, this is the x-axis and this is the y-axis. We plot a point of suppose of 3, 4. Okay, we plot a point 3, 4. So where does 3 occur? Okay, in x-axis is the origin. In x-axis the 3 occur the right hand side of x-axis. Suppose is a 3. and 4. The second value is a y-axis. 4 occur is assumed here is 4. So we related in x-axis 3 and y-axis 4. So it is the point indicated 3, 4. So now we say this 3, 4 is an ordered pair. I give one example. Suppose we are going to see a film in the theatre. Suppose the allotted seat is our 10th row, okay, and the 6th seat. Go to film. Suppose allotted seat is in a 10th row and 6th seat. How to write in this ordered pair? First of all, we go to C, 10th row, and will be seated in the 6th seat. So 10, 6. So it is the useful in our daily life of the ordered pair. So pair means there will be two value, and we arrange some manner. For example, this one 3, 4, and you go to use a film. 10th row 6 will be allotted is 10, 6. Suppose another one row is allotted, another one seat is allotted. For example, the 5th row is allotted to us. Okay, so first one is 5, and the 12th seat is also allotted. So 5, 12. So it is the example of the ordered pair. And the next one definition is the Cartesian product. Okay, it's a Cartesian product. So Cartesian means it's a two-dimensional, that is x-axis and y-axis in our lower class. Here also we see there will be a two number. In Cartesian product we need there will be two sets. One set is A and another one set is B, and also these two sets are non-empty sets. Now I also explain what is meant by a non-empty sets. A set is a collection of some elements we already know. So a set is contains at least only one of the elements. Okay, is a non-empty set. Suppose a element contains there is no elements, is called a empty set. Okay, I give an example. Suppose A 1, 2. We say this set A is a non-empty set because it has two elements. The elements are 1 and 2. So this is the non-empty set. And another one sets B is contains just only one element. The element is E. So we say these two sets are called the non-empty sets. Okay, because A contains two elements 1 and 2, and B contains at least one element E. So these two sets are called the non-empty sets. Okay, what is meant by an empty set? Suppose a set contains there is no element is called the empty set. Okay, give an example of an empty set. Yes, suppose a set B. The set B contains there will be 5 legs in the human. It's impossible. All the humans are just 2 legs. Suppose we identify there will be 5 legs in the human. So it's impossible. So we say it is an empty set. So the set contains that there is no elements. So we write these two parentheses, there is no element, this is called the empty set. Or using the symbol, it's an empty set. Or in symbol we say it is also a pi. So this is the empty set. Now we will be taking the two non-empty sets because all the two sets at least having minimum only one of the elements. In these two sets we assume how to read. Okay, Cartesian product. So A cross B, we should be read in the symbol cross. A is the first set and B is the second set. So we interchange these two, A cross B. So how to define A cross B? You should be read it as A cross B or A Cartesian B. We write in the ordered pair A comma B, but it satisfies on condition. You know what is the name of the symbol? This is called such that. Okay, it satisfies on condition. The first element A should be lies in the first set A. The first element A should be lies in the first set A, and the second element B, it should be lies in the second set B. So this is the definition of a Cartesian product of any two sets. The first one is the given two sets, it should be non-empty. And how to define the Cartesian product of these two sets? Within a ordered pair is any element, suppose A comma B, it satisfies one condition, that is such that the first element should lies in the first set and the second element should lies in the second set. Okay, to write all the elements, suppose it has only one element, it has only one ordered pair. Suppose both the sets have so many elements, so many ordered pair will come. So it is the definition of a Cartesian product. Now using this Cartesian product, we use some problems. In exercise 1.1, it's the first sum. We find A cross B, A cross A and B cross A. That is the Cartesian product of A and B, same A and A, and in reverse B and A. There will be two sets are given. The sets are one is A and another one is B. We say the name of these two sets is first of all is a non-empty sets because it contains some elements. What are the elements? A contains three elements. The elements are 2, -2 and 3. And B is another set. It contains two elements. The elements are 1 and -4. Now we find these two, according to these two sets, we find the Cartesian product. So I write elaborate. A is a set, it contains three elements, 2, -2 and 3. Cross product B is another set, the values are 1, -4. Now we write all possible order, okay, all possible ordered pair. So what are the all possible ordered pair? First of all, what is the first element in the first set? The first element in the first set is a 2, okay, 2 is going to the second set B. What is the first element? 1. So now we write all possible ordered pairs, okay. So the first element is 2 and the second set the first element is 1, is a one possible way and another possible way. In the first element of the first set is 2 and the second element of the second set is -4. So we write 2, -4 is a one possible way. To write all possible way, we write all possible ways. So first one 2, 1 and second one 2, -4. In the same way we move the second number and third number in the first set. Okay, what is the another way? We move to the next number is -2. So -2 in the second set it maybe goes to 1. So -2, 1. Next one, this -2 is approaches to -4. What are the next possible? What is the next element in the first set? Is 3. So 3, is going to the second set, first element is 1. So 3, 1. Next one, this 3 is going to the element is a -4. So it is a working rule to write the Cartesian product of any two sets. Now we write all possible ordered pairs. Okay, we already write the definition of A cross B. What is the definition of A cross B? In the ordered pair A, B, it satisfies one condition. The condition is the first element lies in the first set and the second element lies in the second set. So now we write A cross B. So A and cross B. Now you see all the elements. In the first element always lies in the first set A. You see 2, 2, -2, -2, 3, 3. And you see all the second element lies in the second set. Okay, second set is B. 1 lies in second set, -4 lies in the second set. In the same manner 1, -4, 1 and -4. So you don't leave any one of the ordered pair, you collect all the ordered pair. So it is a working rule to write the cross product of any two sets. So now we write A cross B. What is the next question? Is A cross A. So the cross product of two same sets A and A. That is the Cartesian product of two same sets. So A contains the elements of 2, minus 2 and 3. Again cross A, 2, minus 2 and 3. So now we write the cross product of these two sets. So same working rule. First we put. Next, the ordered pair, always in ordered pair, the first element lies in the first set, the second element lies in the second set. Here the first set is A and the second set is also A. So how to write? Always we keep the first number 2, comma. In the second set also, what is the first number? 2. So the first ordered pair is 2, 2. Next one. You don't change the first set number 2, comma. Here we move. What is the next number of 2? Minus 2. So 2, minus 2. Next one. Same 2, comma. In the second set, what is the third number? Is 3. It's a one possible ways. 2, 2, 2, minus 2 and 2, 3. How you say the another way? The another way to write the ordered pair is, what is the next number of 2 in the first set? Minus 2. So we write here minus 2, comma. Here the first number is 2. Next one minus 2, comma. We move minus 2. That is minus 2, comma, this plus 2 and minus 2, comma, this minus 2. The next possible way of order pair is minus 2, 3. Next, another chance is also there. Whatever the third element in the first set is 3. So 3 is approaches to 2. So 3, 2. Then 3, minus 2. Then 3, 3. So we write all possible ordered pair. So A cross A, that is the cross product of two same sets. And another question, the third one is B cross A. Here the first set is B and the second set is A. So first we write the set B. B contains how many elements? There will be 2 elements. 1 minus 4. Okay, is the value of B. Cross A. The next one is A. What is the values of A? Is 2, minus 2 and 3. Now we write the cross product of these two sets. Now we say is a very well known. So what is the first ordered pair? You know, I will tell the answer. What is the first ordered pair? The first ordered pair is 1, 2. Because 1 lies in the first set and this 2 lies in the second set. So one way. Another way is also possible. 1, okay, this 1. We are moving the element in the second set. Okay, 2. What is the next number of 2? Is minus 2. So 1, minus 2. Next order possible is 1, yes, 3. Okay. Next, we write all possible order in the first number and all the remaining number in the second set. Another way, what is the second number in the first set? Minus 4. This minus 4 is related to 2, is one way. Next way, minus 4, minus 2. Next, here minus 4 and here 3. So minus 4, 3. We see in all the cross product only one working rule. In all the ordered pair, the first number or letter lies in the first set and the second number or second letter or anywhere is lies in the second set. So to tell all possible ordered pair, you don't leave any one of the ordered pair, we say all the possible ordered pair. So now you see there will be a 3 cross product here. One is A cross B and again another one is A cross A and the third one is reverse B cross A. Now you know very well, you understand how to write the cross product of any two non-empty sets. In the second subdivision, the question is same, A cross B, A cross A and B cross A, but the sets are differ. Here A is equal to B is equal to P comma Q. So both are contains the equal number of elements. What are the elements? P and Q. Now we find the same three, A cross B, A cross A and B cross A. Okay. Now I say all the three Cartesian product have the same number of elements. Do you identify? So now we explain A cross B. The first question is to find A cross B. So how to write? First we write the set A. What is the set A? P comma Q cross B. B is also contains the same number of elements, P comma Q. Now we write the Cartesian product of these two sets. You know very well how to write. What is the first possible ordered pair? The first element in the first set, comma, the first element in the second set. So P comma P. The next one, first element in the first set, comma, second element in the second set. What is second element? Is Q. Next, first element over. Next, second element in the first set. What is the second element in the first set? Is a Q, comma, first element in the second set. What is the first element in the second set? Is P, comma. Next, second element in the first set, comma, second element in the second set is a Q. So we write all possible orders. Okay, P comma P, P comma Q, Q comma P and Q comma Q. So it is the value of A cross B. What is the next question? Is A cross A. A cross A. A value is P comma Q cross and A value is again P cross Q. So A cross A is also, I say, same as all possible order, because here A and B contains a equal and same number of elements. So A cross A is also same. And what is the third one? The third one is B cross A. Do you identify what is the elements occur in B cross A? B cross A is also lies, I say, all are the same. Do you identify? Because B and A all are contains the equal number of elements and also the same elements. So suppose we write B cross A, the value of the element B is P comma Q, and again A is also the same value P comma Q. So in this sum we find 1, then the remaining 2 is very easy one. So it is possible only when both the sets contain equal and same number of elements. Okay, so is the value of A cross B, A cross A and B cross A. In third subdivision, we find A cross B, A cross A and B cross A. The two sets are A contains two letters M comma N, and B is, what is the name of the symbol? It is called pi. That means it's an empty set. So B contains, there is no elements. So we write is a given A matrix. So B is a pi. Okay, pi means it's an empty set. How to write in symbol? So in our exam, there will be two types of symbol given. It is also known as the empty set symbol, or it is a pi. So two sets are given. A is M comma N and B is an empty set. Now we find A cross B first. Okay, A. The letter A contains two elements, is M comma N cross B. B contains, there is no element, is a pi or an empty symbol. So now I use these brackets. So we write now A cross B. What is the working rule to write the Cartesian product of any two sets? In the ordered pair, okay, in this ordered pair, the first element lies in the first set and the second element lies in the second set. Okay, so first element is okay, M comma. What is the first element in the second set? No one is there. So we can't write a ordered pair. In the same manner, the second number also, there is no element in the second set. So what is the value of the cross product of A cross B? So it is also an empty set. So it is not possible to write A cross B, because in the ordered pair first element is okay, but there is a second element is not lies in the second set. So here A cross B is also an empty set. So we can't write A cross B here. So A cross B is an empty set. And the second question is A cross A. A, the value of A is m comma n. Cross, what is the second set? Is also A. The value of A is again m comma n. A cross A is also an empty set. A cross A is a non-empty set, because the first set contains some elements and the second set is also contains some elements. So okay, how to write the first ordered pair? What is the working rule? We will be take the first element in the first set. What is the first element in the first set? M, comma the first element in the second set. What is the first element in the second set? Is also m. So first ordered pair is m comma m. What is the next ordered pair? The next ordered pair is first element in the first set, comma second element in the second set. What is the second element? N. So m comma n. The next possible order is the second element in the first set. The second element in the first set is n, comma the second element in the second set. Okay, the second element in the second set is n. So A cross A has 4 elements is possible. Okay, m comma m, m comma n, n comma m, and n comma n. And one more question will be given, that is a B cross A. What is the value of the B? Is an empty set. Okay, cross A. A contains 2 elements, is m comma n. If you understand very well, you tell the answer. What is the value of a B cross A? If you listen very carefully, we tell the answer. What is the value of B cross A? The value of B cross A is an empty set. What is the reason? Here the first set B is an empty set, so there is no element in the first set, but some element in the second set, okay, but in the first set there is no element. So we can't write a ordered pair, because first one is an empty set. So the value of B cross A is also an empty set. So what is the conclusion? So we write the Cartesian product, both the sets, it should be a non-empty set. Suppose any one of the set is an empty set, the cross product of or the Cartesian product of these two set is also an empty set. It's a good example. One is an empty set, so whose cross product, that is A cross B, is also an empty set. Whose reverse, B cross A, one is an empty set, so B cross A is also an empty set. The second question, A set's value is 1, 2, 3. The set A contains 3 elements, and B contains elements is X. What is the name of the symbol? It's called such that X satisfies one condition. X should be a prime number, and also which is less than 10. You know very well, the form is called a roster form, is a set builder form. So now we write to convert all the sets in a roster form. A roster form is we write the all elements. It is easy way to write the Cartesian product of any two sets. Okay, given first of all, what is the set A? The set A value is 1, 2, 3. So we write the sets with the number or letters or some words is called the roster form. You know very well in the 9th standard. So first step to convert all the sets in the roster form, that is in elements form. The first one is no problem, is in roster form. The second one is also we converted into the roster form. Okay, the set B contains all the elements are X, but X satisfies one condition. X it should be a prime number, and also which is less than 10. You know very well what is meant by a prime number. A prime number is a number which is divisible by itself and by 1. Okay, it's called a prime number. So now we write all the prime number and also which is less than 10. What is the first prime number? The first prime number is 2. 2 is the only even prime number. And the next prime number is 3. The next prime number is 5. The next prime number is 7. So these are the prime numbers which is also less than 10. Okay, we can write the number is less than 10. So the possible numbers are 2, 3, 5 and 7. You know already very well known in prime number. Suppose I give an example is not a prime number. Now I write all a prime number because the number 2, first number is 2. 2 is possible to divide by 2. Okay. And also you know very well every number is divided by 1. So 2. So there will be just 2 chances only possible in 2. So we say 2 is a prime number. 3. Next 4, I can't write the number 4 because 4 is not a prime number because 4 is divided by 4. Okay, so one way. And 4 is also divided by 1 is possible. 4 by 1 is 4. But one more way is also there. The 4 is also divided by 2. Okay, so it will divide in 3 manner. So 4 is not a prime number. But 2 is a prime number because it is possible only when these 2 number. So this is a example of is a prime number and it is not a prime number. So now first step is to convert the given set in roster form. Roster form means all are right within the parenthesis symbol. It may be the numbers or letters or some words. It is easy way to write the Cartesian product of these 2 sets. So given A is a 1, 2, 3, that is a roster form. The second set is also the first work is to convert the given set in roster form. What is the name of the symbol? Such that B contains all the elements are X, but it satisfies one condition such that this X number is a prime number and also which is less than 10. So the possible numbers are 2, 3, 5 and 7. So now we write A cross B and B cross A. So first we write A cross B. A, the value of the set A is 1, 2, 3. Cross B, the value of B is 2, 3, 5, 7. So it's the first set A cross second set B. How to write A cross B? We already say how to write the Cartesian product of any 2 sets. What is the first possible ordered pair? The first possible ordered pair is first element in the first set. Next, comma, we write the first element in the second set. The second set element is a 2. It's a 1, 2. The next one is we don't change the first set elements. We move the second set elements. It is easily, you don't miss any one of the ordered pair. So 1, 2. Okay. Next one is a 1, the next number of 2 is 3. Next is this 1, the next number of 3 is 5. Next 1, the next number of 5 is 7. So 1, 7. So the first element and the second set all elements are completed. What is the another possible ordered pair? We move. The second element of the first set is a 2. So 2, here the first element of the second set is also 2. Next one is a 2, we moving 3. Next this 2, 5. The next one is 2, 7. Okay. Next we moving the third number of the first set. What is the third number of the first set? Is a 3. 3, yes, 2. Next 3, we moving is a 3, 3. Next one is a 3 comma 5. Next one is a 3 comma 7. After writing the Cartesian product of these two sets, just we check, we write all the first number or letter lies in the first set. 1 1 1 1 all lies in the first set. 2 2 2 2 all lies in the first set. 3 3 3 3 all lies in the first set, no problem. And the second element in the ordered pair, second element all lies in the second set. 2 3 5 7. 2 3 5 7. So finished. The second 2 3 5 7. Yes. And third one is also 2 3 5 7. So now we check the Cartesian product of these two, A cross B. The next one is the reverse, the Cartesian product of B cross A. So B cross A. So what is the first set is B, and what is the second set is A. Now we write B cross A. The first set is B. B contains 4 elements. The elements are 2 3 5 7 cross. The second set is here A. A value is 1 comma 2 comma 3. If I identify very well known, you tell all possible order. So what is the first possible ordered pair? The first possible ordered pair is 2 comma 1. Yes, 2 comma 1, because the first number 2 lies in the first set and the second number lies in the first number of the second set. Is a one possible ordered pair. The next one is 2 comma 2. Okay. The next one is 2 comma 3. The first number, we finished all the number in the second set. We are doing the same work. The next work is we are moving the element in the first set. What is the second number in the first set? Is 3. Okay. So this 3 is going to the first element in the second set is 1. So 3 comma 1. The next order pair is 3 comma 2. 3 comma 1, 3 comma 2. The next order pair is 3 comma 3. Finished. What is the next possible order pair? We finished all the number of 3. Next we are moving, the next number is a 5. So first order pair is a 5 comma 1. And next one is a 5 comma 2. Next is a 5 comma 3. What is the next possible order pair? Is the next number of 5 in the first set is 7. So 7 comma 1, that is the first number in the second set. The next one is 7 comma 2. And the last one is a possible order pair is 7 comma 3. So it is a working rule to find the Cartesian product of any two non-empty sets. So I do, there will be a 3 sum in the exercise. In one, the question will be same, A cross B, B cross A or A cross A. But it is a working rule to find the Cartesian product of any two sets. In the same model, there will be some example sums. The answer is also there in your textbook. If you try to find the Cartesian product of these sets, if you have a doubt, I tell again one more, the cross product or the Cartesian product of any two sets. It's a very easy. If you understand, it is very easy. So I will take 3 sums, the Cartesian product of two sets. So Cartesian product of two sets is when possible. First of all, these two sets, it should be an empty set. If any one of the set is an empty set, the Cartesian product is also an empty set. So you try the examples. If you have a doubt or if you have any doubt questions, so I will tell again. Third question, the value of B cross A, that is a Cartesian product of these two sets, is given. The possible all order pairs are -2, 3, -2, 4, 0, 3, 0, 4, 3, 3, 3, 4. Then to find A and B. It is the reverse of the previous questions. In previous, there will be a sets given to write the Cartesian product of the sets, but in the third one, Cartesian product are given to find the sets. Okay, it's a reverse question. So given the Cartesian product of these two sets B cross A is lies all the elements. Now we find what are the elements or lies in the sets A and B. You know the Cartesian product working rule. In this ordered pair, the first number is always lies in the first set, and the second number is always lies in the second set. But here what is the first set is B, what is the second set is A. So the first possible value of the set B is, what is the first possible number in the set B? Do you identify? The first number is, I say, minus 2. Okay, so first number is minus 2, because you see minus 2 lies twice, or so many ways is also there, we write only one time. Okay, so the value of a B is minus 2, first one. What is the next possible number? Is a minus 2 is there. If it lies at 2 times, 3 times or 4 times, just we write only one time, is a minus 2, comma. What is the next number is possible is a 0. Okay, 0, 0. What is the next number is also possible is a 3, 3. So these are the possible elements of B. So listen very carefully, it's not A cross B, it is B cross C. Okay, B cross C. So the first element is always lies in the first set. Here what is the first set? The first set is B. So B contains these 3 elements. And you say what is the possible numbers or values of the set A? Do you identify? A is the second set. So in this ordered pair, the second element is only lies in the second set. So what are the second elements in the first ordered pair? Is a 3. The next one is, the next number is 4. The next number is again 3, 4, 3, 4. So these are the values of A. Now we check. Suppose we write a B cross A. What is the first possible ordered pair? Minus 2, 3 is there. The next possible ordered pair is minus 2, 4 is there. The next one is 0, 3, 0, 4, and 3, 3, and 3, 4. So this is the reverse of the previous. In previous, sets are given to find the Cartesian product, but in this question, the Cartesian product of two sets is given to find the individual sets. Okay, so it is also a working rule to find A and B. Our question is to find the value of the sets A and B. We find B and A. In result, we write in alphabet order. The first one we write the set A. The first set A values is 3, 4, and the second set is B. The set B is minus 2, 0, 3. So now we know very well how to write the Cartesian product of any two sets. And in reverse, suppose Cartesian product is given, how to write the elements of the sets. So doing the same model or same question will be given in the example sum also. You try all the examples regarding in this exercise problem. There will be a 2 example sum is there. You know very well, you understand all the problems. So you must try the example sums.